All right, guys. So today we're looking at section 6.63. What we're going to be doing today is we're going to be solving some complicated exponential log equations. We're also going to look at some exponents, and we're going to work with simplifying with exponents. These first two problems, we already did these, and I want you to now do them without looking at your notes. I just want you to help me with them. So don't look back at how we already did these. I just want to see if you can remember how we started these. We're not going to do the whole thing, but how did we start it? So we had to factor this, and we have 3 to the 2x. Do you remember how we get 3 to the 2x? Correct. Then we have to look here, and we have to think, what are numbers that multiply to be 15 and subtract to be 2? What were those numbers? And I wanted to get, when I multiply those two, I get 3 times 3 to the x. These two, I get 5 times 3 to the x. Can I multiply the 3 and the 3? No. Bases cannot change ever. All right? Unless we use change of base formula. So we're trying to get -2 of these. So that's the reason why we had a -5 and a +2. Oops, -5 and +3 rather. And then we just set them equal to 0. Okay, not going to finish, but that's the first step. Okay, what about on this? If I look at this one, I had log base 2 and I have log base 4. We have a change of base formula up on the board, which will not be there when we take our test, so we have to know those. But we should know that if I have log base A of B, that's the same as log base C of B over log base C of A. What this is saying is if I start with a base of A, I can change to a base of C as long as I put the B value here and I put the A value here. So this already has a base of 2. Can I rewrite this with a base of 2? Yeah, I can write it with the base of anything. I'm going to choose 2 though so that it matches. So the first step on this was log base 2 of x. If I want to use log base 2, what is in that B position for this? Not just x, but 8x. So it's going to have to go log base 2 of 8x over what? Log base 2 of 4. And on these kind of problems, there's going to be something that you can evaluate. Can I evaluate log base 2 of 4? It's just 2, right? 2 to the what is 4? That's 2. So then we had log base 2 of x equals log base 2 of 8x over 2. What can you do now? Let's just talk through it. Multiply by 2. What does a 2 become for a log? Exponent, and then they're going to match exactly. So we're going to end up setting x squared equal to 8x and solving. We would also have to think about the domain because we're starting with a log. If we start with an exponent, we don't have to worry about the domain because it's all real numbers. But if we start with the log, we do have to worry about the domain. What's the domain here? X must be greater than 0. So if I get an answer for x that does not meet that requirement, I'm not going to use it as a solution. Okay? So that's just an overview. We already did those problems. All right. Let's get going now. Number 3. I have 81 to the log base 3 of 2. That is not helpful the way it's written. But I have a formula up at the top that says this. B of log base B of x is going to equal x. All right? But do you notice in this formula that the base here has to match the base in the exponent? What is our base up there in the exponent? 3. So I have to rewrite this with a base of 3. How can I rewrite 81 with a base of 3? So I'm going to have 3 to the 4th log base 3 of 2. Well, the formula says I have to have b to the log base b of just something here. That's not what I have. I have a coefficient that I can't have. So what do I do if I have a coefficient with a log? make it an exponent. So I have 3 to the log base 3 of 2 to the 4th power. What is 2 to the 4th power? 16. So we have 3 to the log base 3 of 16. Let's see if it matches. B. Okay, and it all matches up. So what's our answer? 16. If I'm taking the ACTs, I'm not going to mess around with that though. I'm just going to type this into my calculator. It doesn't have an X in it. If there's no X, I can just type it in. 81 raised to the math log base of 3, log base 3 of 2. Push enter, 16. Okay? Now remember before we'd have X's in there. If you have X's in there, that's not going to work. But if all we have are constants, we can check it like that. All right. We have another formula. Well, actually, this is the same kind of problem. You guys try this on your own. Okay, you should have it by now. What is it? 125. If you didn't quite have it, all I did was rewrote my base of 8 as a base of 2 so that they would match. It's 2 to the 3rd. The 3 becomes an exponent. 5 cubed is 125. All right, moving on. This kind of problem here. Okay. Yesterday, I showed you how to do this problem or Tuesday rather, but how did we start this? What did we do first? Took what? Right. So we took log base 2 of both sides to get this to cancel out. Now, guys, you don't have to take log base 2. You could take log base 10. All right. Any log base you choose will work. It's just that some ways are a lot easier than others. Okay. So we did this with log base 2, and we can certainly do it that way. I want you guys to do this with log base 2, but I'm going to do it with log base 10. I just want to show you because there's just so many different ways to work with logs. So you guys go ahead and start with log base 2. Yours is going to look a little bit different than mine. Are you getting close to being finished with yours? Okay, keep going. I want you to look at mine and see if you can understand how I went from this to this. I think you guys, when you use log base 2, you're also going to have that opportunity. Like, do you guys have a coefficient that you could make an exponent somewhere in your answer? I always like to do that because it's easier to type it in. Okay, here's what I got for my exact answer. I'm going to find my approximation. Guys, one thing though, before I start, my other class, they kept doing this. They're like, I'm going to cancel these log 2s out. You cannot do that. If it's addition, you cannot cancel terms. That's not going to work ever. If it's multiplication, you can cancel factors, but you cannot cancel terms if you have addition or subtraction. For my answer, this is what I get. Does anybody have the exact answer when you use the log base 2? Be brave. Just tell me. I don't care if it's right or not. Somebody has it, right?
3 log base 2 5.
Yeah, 3 log base 2 of 5. Okay.
Log base 2. Right?
All right. Did anyone write this as log base 2 of 125? Okay, you could do that as well. I want to show you how different these answers can look. Did anybody cancel out these ones? Please say no. You cannot do that because these are terms, okay? You cannot cancel out the one. All right, watch this, guys. Go to your calculator now. I'm going to do my alpha y equals. That's the only way on my calculator I can get to the fraction. And I'm going to type this in. Okay, here's my answer. This is what I got. All right, we're going to check Wes's answer now. Guys, and I'm telling you, you have to practice typing these in. Sometimes it's harder to get the decimal approximation than it is to get the exact answer. These are pretty tedious to type in. I have a lot of practice with it, so I can go pretty quick, but you might want to slow. Uh-oh. Those are not equivalent. Did anybody get an answer a little bit different than this? What did you get? You say the one on the top is positive. All right, guys, watch how I can change this quickly. I'm going to go up and grab it, and I'm just going to arrow over and change that. Let's see if that's right. To a plus. There it is. Okay. So did some of you have this answer then? Okay, good. We had a couple people. Guys, you'll have to practice this. So you can, yeah. I can. I'm going to go through it really fast though, okay? Since you've already done it. Let me get that out of the way. Okay. Did you not get actual parentheses rating at plus 3 log base 2 5 per foot? All right, that was a lot of words. So I'm just going to do it up here. Okay, so I'm going to do log base 2. Log base 2, 2 to the x minus 1. Log base 2, 5 to the negative x plus 3. Bring these out as coefficients. That is just going to be 1. Okay, so now that was just a 1 there. So I've got this. I can get rid of the parentheses. Check and see if you have this. Do you have that somewhere? Now I've got to get my x's together. So I'm going to have to take this over here. So this x is going to stay, and I'm going to add this over. And I'm going to go ahead and make this. You guys probably didn't do that, so I won't do it either. But you can make that 3 an exponent. And I'm going to add that 1 over. Check that. And now here's the mistake people typically make. I have an x here and I have an x here. So I'm going to factor out an x, and I have 1 plus log base 2 of 5 equals. I'm going to change this. I think you'll be better off to do the same. 5 cubed is 125. Most of the time, if people missed it, it's because when they factored out this x, they did not put the 1. And so they're missing the 1 down here. The other mistake is just with the signs. Okay? That is the same thing as we have down there, just moving that 3 into the exponent. Avery, could you see where your mistake was?
Yeah, I mean, I got to that point. I just didn't want to do after I,
This?
no, I didn't get that. Like when you wrote the exponent, I two separate codes and two separate blocks. So like I got to that step and I just didn't know that you had to let separate one.
Yeah, so anytime you're trying to solve for x, you have to have everything that has an x in it on the same side. Everything that does not have an x in it had to go to the other side. So this term, this is all together, this has an x in it. So it had to go over here. This does not have an x in it, so it had to go over here. Okay, we'll come back to that later, all right? Okay, let's go to this one, guys. All right, on this kind of problem, the biggest thing you have to look for is anything that can be evaluated at the beginning. A lot of times people are like, oh, I should get like bases. No, you shouldn't, because this over here has a very simple answer to it that will make the problem easier. What is log base 5 of 1? 0. Okay, so I have log base 2 of 3x minus 4 equals 0. Am I going to use change of base? No, I don't need to. I want to get rid of this log. So what's the opposite function for a log? So I'm going to exponentiate the left side, and I'm going to exponentiate the right side. What is the left side equal to? And what is the right side equal to? 1. So I'm going to add 4, and I get 5/3. Question? Now, I have to double check this though. Back up here, 3x minus 4 must be greater than 0. Every log has the fact that this must be greater than 0. So 3x is going to have to be greater than 4, and x is going to have to be greater than 4/3. Is that greater than 4/3? Yeah, so it is a solution. Okay? But that's something that must be checked. All right, down here. These are some of my favorite problems because look at how similar these are, but they're going to have very different answers and very different processes. What does 3 divided by 4 really mean? Well, doesn't it mean that? And it's in parentheses, so that's what I want to do. I have this to the -2 power. To get rid of the negative exponent, I have to flip this fraction over, and now it's going to become a positive exponent. And now to get rid of the squared, I just square the top, square the bottom, and I get 16/9. You should not get the same answer on this one. You guys try this one on your own. I'll give you 1 minute, and then I'll show you what the answer is. Did you get 48? You should get 48. Let's go through it. The problem that people have is that they try to do too much at the same time. I'm going to do it very slowly. I have 3 divided by 4 to the -2 is 1 over 4 squared. That's how I get rid of the negative. Well, I have 3 divided by 1 over 4 squared is 16. To divide by a fraction, I keep the first one and I multiply by the reciprocal, and that is 48. Okay, if you missed it, it's because you were probably trying to get rid of the division and the negative exponent at the same time and made a mistake. All right, let's come down here. Okay, number 9. Here's the biggest mistake, is that 9 and x to the negative 3 are both getting raised to the negative 1/2. Okay? What most people do is they say in the next step, it's 9x to the 3/2. That is wrong. It is not 9x to the 3/2. We have to do 9 to the negative 1/2 and x to the negative 3 to the negative 1/2. What do we do when we have a power to a power? Try again. Okay. Is this 3 to the 1/2 power? No, so it's going to stay the same. Just the x is to the 1/2 power. See if you can finish. Look up and see if you got it. X squared? Very good. 9 to the negative 1/2 is 1 over 9 to the positive 1/2. When my bases are alike, I keep the base, I add the exponents. 1 over 9 to the 1/2 is 1/3 times the 3 times the x squared is x squared. All right, guys, I'm going to do this one with you. Okay, is the 5 to the 1/4? Yes. What's x to the negative 4 to the 1/4 going to be? X to the negative 1. I am going to keep the division, but I'm going to raise each of these to the negative 3/4. So I'm going to have 5 to the negative 3/4 and x to the what? Negative 3. This whole thing is what I'm divided by. You do not want to try to get rid of the division and the negative exponents at the same time. Do you guys want to finish it? I feel like you guys can do it. Try it. I haven't seen any celebrating yet. Did anybody get it? Okay. All right, let's talk about it. So my 5 to the 1/4 is going to stay in the numerator. That's to the negative 1, so it goes to the denominator. Divided by, don't get rid of it yet. Let's get rid of the negative exponents. Both of these are negative exponents, so one is on top. 5 to the 3/4 x cubed goes to the bottom. To get rid of the division, the first fraction stays the same, and I multiply by the reciprocal of the second factor. My bases are alike, so I keep the base and I add the exponents. 1/4 plus 3/4 is 1. Here I have x cubed divided by x to the first. When I'm dividing, I keep the base, I subtract the exponents, and I keep it where it's higher. And so 5 to the first is just 5x squared. Okay, any questions? All right, so we did not need to use logarithms down here. This was just simplifying exponents, a little bit different than what we had been doing. The only time we have to use the opposite operation is when we have an equation that we're trying to solve. So we're trying to undo something. Okay? All right, we're going to stop there and you guys can get some practice with this.